So when we start writing our formulas of ionic compounds, we'll have a lot of examples of these, but essentially the chemical formula is going to show the simplest ratio of anions and cations required for the total charge of the molecule to become zero. So this is an important concept. When you make a molecule, the charge of that overall molecule has to be neutral. So we have to balance the positive charges with the negative charges to make a valid molecule that's going to be stable on the Earth. If there are charged portions of the molecule, they're still reactive and they're not going to exist on the Earth. So they're going to be reactive until they neutralize that charge. So a shortcut then is to try to make the subscript of each ion equal to the charge on the other ion to get the molecule to actually balance. So we have a polyatomic ion here. This is the anion. And so this is a phosphate anion. The PO4 has a -3 charge. The cation in this molecule is going to be magnesium. And the charge on this ion is +2. When we're writing a molecular formula, the cation always comes first. The anion always comes second, and this is true for naming the molecule as well. The cation is always listed first, so magnesium has to come first. And magnesium with the +2 charge and the phosphate with the -3 charge, if we were just to combine one of each of these, the plus charge on the magnesium is not enough to neutralize the negative charge on the phosphate, right? You can see that, right? If we only had one magnesium, we only have +2. If we only have one phosphate, we've got -3. And so if we put those together, the overall molecule would still have a -1 charge. That would not be stable. So the easiest way to make this balance is to say, oh, if we've got magnesium and it's got a +2, we're going to say we'll need 2 molecules of the phosphate. And so remember, number of molecules is represented by the subscripts on our equation. And since this is a polyatomic ion, we have to make sure that we put brackets around it because this entire thing is moving as a unit. And if we have 2 of these present, we need 2 of the entire thing. You can't just have 2 sets of the oxygen. So we have to put brackets around this and indicate that there's going to be 2 of them. If we have 2, what's the negative charge going to be on this overall molecule? 2 times -3 is going to be -6. So there's a net negative charge of -6 because of the 2 phosphate groups. So we know that the charge on the phosphate is -3, and so we're going to say we're going to need 3 of the magnesiums to go with it. So if we say Mg3, how much positive charge do we have present? We've got 3 times the +2. This would be +6 in this case. So we've got +6, -6. The overall charge on this molecule is going to be 0. So this is a stable compound. Mg3, PO4, 2. So this guy, if we named it, is just going to be magnesium. And we drop the ion because it's no longer an ion, it's now a compound. And we're just going to put the name of the anion in there. So this is magnesium phosphate. And remember, you will be given the polyatomic chart. So you'll be given this chart on the test. You just have to be able to look up and say, oh, I've got the PO4 3- as my anion. That's called the phosphate ion. In the naming of the full compound, you drop the words ions because they're no longer ions, and you just name it as the cation next to the anion name. So magnesium phosphate in this case. Notice also that when you draw the compound, the charges are no longer indicated. You do not place the charges up here because they're no longer fully charged molecules. This molecule is neutral. The charge on this thing together is 0 because the +6 is negated by the -6 from the phosphate. So you do not show any charges. If you place a charge up here, that indicates that this overall molecule still has a charge on it, and that would be incorrect. So this is the way that we actually build our molecules. You'll get a lot of practice at building ionic compounds. And so we'll do a little bit of video work as well to do some demonstrations of making our molecules. So once the numbers and the kinds of ions in the compound are known, the formula is going to be written using our following rules. So this is kind of a summary of what we just did. You have to list the cation first and the anion second. So if you've got sodium chloride, the sodium has to come first and the chlorine has to come second. You would never write it this way. You never put the anion first and then the cation. Cation comes first, positive first, negative second. Then you have to eliminate any common factors from the subscripts. So, for example, if we have magnesium oxide, we would write it as MgO because the magnesium takes on a 2+ state. It's in the group 2 family. Oxygen is in group 6, so it's going to take on a -2 charged state. And so you only need one of each to get a neutral compound. It is incorrect to write it as Mg2O2. This is not the most simplified form. You can cancel this out and you can just have one of each. And then it's very important not to write the charges on the ions when you have the compound. So potassium fluoride, for example, would be written as Kf. It would not be written as K+ and F- because those charges in this overall molecule now are neutralizing each other. There is no overall charge on this molecule. If you continue to represent a charge up here, that would be incorrect because there is no net charge. They cancel each other out. And then for our polyatomic ions, if the formula has a subscript like we did with the phosphate, you have to use brackets to indicate that subscript. So when brackets are around the sulfate that we have here, the SO4 polyatomic ion, this tells us that we have 3 of the sulfate molecules. If we write this way, what does this indicate? We've got 2 aluminums, we've got 1 sulfur, and we have 43 oxygens. So this would be the incorrect way to write this polyatomic ion. If you want to say you have 3 of the sulfate ions, you've got to use brackets and you've got to include the sulfur in there. So this says that I've got 3 SO4 molecules.